Hey everyone, welcome to Fresh Library YouTube channel. Today in this class, we are going to discuss about bitwise operators. Bitwise operators. Uh, by the end of this class, you are able to learn about what is bitwise operator and what are the different kinds of bitwise operators we have in Python and how to give different kinds of bitwise operators as input to the IDLE, how to perform operations by using bitwise operators. Okay, by the end of this video, you are able to learn all this. Okay, and in the last class, we have discussed about ternary operator. Okay, uh, guys, I'm sharing the screen. So here, we have discussed about ternary operators. In ternary operators, we have discussed about how to give the inputs in ternary operators. What are different kinds of ternary operators we have? Okay, and how to perform if else conditions. Okay, till now, in the last class, we have discussed about these. Now we are going to discuss about bitwise operator. Bitwise operators. This is the seventh one. Bitwise operators in Python. Is operator. Yeah, in the last class we have in the last 1 minute, guys. Okay, yeah. So in the last class we have discussed about ternary operator, assignment operator, logical operator. Okay, different kinds of operators we have discussed. So today we are going to discuss about this bitwise operator. So what are the different kinds of bitwise operators in Python? Are first one and symbol and operator. Okay, and sorry is dollar, and second one R, third one caps, next fourth one negation, fourth one negation. Yeah, here I'm going to take this symbol here because in my keyboard that symbol is not working, so that's why. Sorry, I'm taking this symbol from another source. Okay, and we are having left shift also, left shift and right shift. Okay, these are the bitwise operators we have in Python. Okay, first one is and, second one is or, third one is caps, uh, fourth one is negation, and next one is left shift, and last one is right shift. Okay, so I am going to write the notes for these to know more about these operators. Okay, so we can apply these operators bitwise. First thing we have to remember is we can apply these operators bitwise. Second point is I will explain this in practical also. Okay, first I am going to write the notes for this one because we need to remember these points while uh, doing practice. Okay, these operators, these operators are applicable only for integer and boolean types. Int means integer and bool means boolean. Bool types. Okay, so integer means numbers and bool means true or false, like that. Next, what are the rules for these bitwise operators are? First, I am going to write the rule for AND operator. For AND operator, the rule is if both bits if both bits if both bits are 1, then only result is 1. If both bits are 1, then only result is 1. Otherwise, result is 0. Otherwise, result is 0. Next thing. So this is the rule for AND operator. Now I am going to write the uh, rule for OR operator. If if at least one bit is if at least one bit is 1, then the result is 1. If at least one bit is 1, then the result is 1. I will explain this in practical also. So uh, give me a moment for doing practicals. Okay. Otherwise, otherwise, result is 0. Otherwise, result is 0. Next thing. Next, I am going to write the rule for dot operator. Give me a minute, guys. Just give me a minute. Yeah. Okay. So the rule for the third operator is mm, XOR, sorry, XOR. If bits are different, if bits are different, then only result is result is 1. Otherwise result is 0. Okay. If bits are different, then only result is 0. Okay. Next, the rule for negation. Bitwise complement, negation or complement we can call complement operator. So this means that if it is true, then the result will be false. If the input is false, then the result will be true. Like that, it will operate. Okay. So here, example of this is if we give 1 as input, then the result will be 0. And if we give 0 as input, then the result will be 1. Okay. So each and everything we are going to uh, explain ideally by opening ideal. Yeah, I'm opening ideally. So here, first we need to remember the rules. Okay. What we have discussed about AND operator, if both bits are 1, then only result is 1. Okay, that's why. So here I am giving 4 and 5. 4 and 5. So the result will be 4, because if we did not give the zeros, we have given numbers means ones only, right? Okay, so both, if 4 and 5 both are concerned, takes as a number 1. Okay, so that's why it has given as 4. Okay, and next to OR operator, I'm giving the same kind of inputs for OR operator. So here I'm giving 4 So with negation, right? So four or five. So the result will be 5. So what is the rule for this four R operator is if at least one bit is 1, then only the result is 1. Okay. If at least one bit. Okay. Instead of 0, if at least one bit is 0, I mean one bit is 1, then only the result will be 1. Okay. And I am giving here 4 complement 5. Oh, sorry. 4 caps are complement of, okay, complement 5. So the result will be what? 1. How these operations will perform is there is a logic behind these operators. There is a logic behind these operators. What is that logic is? See here. So here I am going to give the logic behind these operators. Why it is giving that kind of inputs. So here first we need to go through AND operator. In AND operator we are giving first 0 and 0. So 0 and 0 means 0 into 0. 0 into 0 equal to 0 only, right? So here. So 0 into 0 means 0. And next 0 into 1. 0 into or and we can call 0 and 1. Next 0. Next 1 and 0. 1 into 0. 1 into 0. Next 1 into 1. 1 into 1. 1 into 1 equal to 1. 1. Next 1 into 0 means 0. And means we can call as into for understanding purpose. But in technical terms we have to call and only, but for understanding we can call it as into. Okay. So 0 into 1 means also 0 only. So now observe the rule. If both bits are 1, then only result is 1. Okay. If both bits are 1. So here not both bits are 1. So first two are zeros only. Here also not both bits are 1. Okay. One is 0 and another one is 1. And here also both bits are not ones. That's why it has given 0. Here the only in fourth condition only both bits are 1, then all that's why it has given 1. Okay. This is about AND operator. Okay, this is about AND operator. Then what about OR operator? So for OR operator I am giving the same kind of input, but the result may vary. Instead of AND we have to give OR. Control C. So 0 or 1. 0 or 1. 0 or 1. 1 in 1 or 1 or 1. Okay. So here the rule here is if at least one bit is 1, then only the result is 1. If at least one bit is 1. So here both bits are 0 means 0. So here at least one bit. So one we have given 1 as its one input. So that's why it will give 1. And here also one bit is there, 1 is there. That's why it will give 1. So here both bits are ones. That's why it has given 1. Okay. The rule is satisfied. Okay. Because at least one bit. Here at least one bit in second condition, third condition, fourth condition, we have one. That's why it has given 1. Next, for caret symbol. Caret means caps or caret we can call. In technically we have to call as caret. For understanding purpose we can also call it as caps. Okay. So here first yeah, yeah, 0 caret 0 and 0 caret 1 and 1 caret 0 and 1 caret 1. Okay. 0 caret 0, 0 caret 1, 1 caret 0, 1 caret 1. So what is the rule for this? If bits are different, then only result is 1. Otherwise, result is 0. So here both bits are say 0. So there is no change in inputs. That's why it is given 0. Here one bit is both bits are different. That's why he has given 1. And one bit is here also both bits are different. That's why it has given 1. So here both bits are same. That's why it will give 0. Okay. This is about uh, caret or caps symbol, or in logic gates we can also call it as a XOR. Okay, we are having different kinds of logic gates like and, or, not, NAND, NOR, XOR, OR. Okay, so for caret symbol, I told about that logic gates in electronic device and circuits, not in Python. In Python, we don't have that much logic gates. Okay, mostly we will use and or uh, caret. Okay, these kind of logics only or logic gates only. So for example, we can take a caret as a XOR gate. Okay, this is about caret symbol. And next, bitwise complement means bitwise complement means if you give here already I have specified example. If you give 1, it will 0. It will give 0. If you give 0, then it will give 1. Okay. Next, we have to discuss about left shift operator and right shift operators. Okay. I'm going to specify the outputs, inputs and outputs are here, these outputs. Four and five output is 4. 4 or 5 output is 5. 4 caret 5 output is 1. Okay, next we are going to discuss about left shift operator. What is the last one? We have discussed about all these. Then we have the remaining ones are left shift operator and right shift operator. Now we are going to discuss about left shift operator. Left shift operator. So here left shift operator, how it will work is actually in binary bits operations. This computer or any programming language we will use 8 bits operations. Okay, 8 bits operations. So what are that 8 bits are? Let's assume, just wait, here I am going to specify. So here I am going to give 10. Okay, what will be the binary output of this 10 is the binary output of this 10 is 0 0 0 0 and 8421. We have to represent first 8421. So here 8 and 2. So 8 under 8 we can write 1 and for 4 0 and for 2 1 and for 1 0. So now we have to combine these values. So whenever we have specified 1, then we need to represent that as 8. Okay, so we have to consider those numbers. Okay, so here under 8 we have given 1, so this value is 8, and in 4 under 4 we have given 0, so we don't need to calculate this 4, but for 2 we have given 1. Okay, so this value is 2, so now the 8 plus 2 we have to combine this 8 and 2, that the output will be 10. Okay, so first 4 digits it won't calculate, but for understanding and for consideration it will take 8 bits. So these are 4 bits, these are 5 bits, right? Yeah, this will take another 4 bits. Okay, here 4 bits, 4 plus 4 8 bits. Here I am going to give here this an 8-bit input, 8-bit input. Okay, students who are from electronic background or CSE background, then those people only easily understand this. If you can also understand this logic by watching our previous videos. Okay, so this is an 8-bit input. What is the 8-bit is here we have given 8 bits: 1 2 3 4 5 6 7 8. So these are called as 8-bit input. Okay, and how to perform this and how to calculate these 10 in binary operations is like this. So here we have to give one space. Otherwise, for understanding, we can also give extra spaces between these numbers, then only you can easily understand. Okay, now calculate the numbers at the beginning of the associated number, then only we had to consider that numbers. Okay, so here in 8 we have given 1. Okay, in under 2 also we had given 1. So we have to consider those who has the 1 value. Okay, we have to consider the values that has 1 value. So here 8 has 1 and 2 has 1. We have to combine these two. 8 plus 2, 8 plus 2 equal to 10. Like that it will represent. Okay, now if you want to do left shift operation in these, then how can we it will represent is it will shift the values from right to left. It will shift the values from right to left. Okay, so here we have to shift two values, then how it will represent. So here we will add some more zeros to the 10. Then see the output. Then see the output. So here we have to give yeah, otherwise we can take another line for understanding this. Okay, so 8421 we have added 2 digits for this. Yeah, now it's correct. 8. So here the value will be 16, right? 16. And here the value will be 32. Okay, so otherwise we can annotate this one for understanding this one. We will annotate. So here first we need to take one more example. 1 0 1 0 0. Okay, so here the value here is 32. Wait. 32, like this. So the 1 will come goes to 32 and 16 is 0. Okay, 16 is 0 and for 8 1. Okay, like that 16 means 0, 8 means 1. Like that we have to take. Okay, so here each and every time it will increasing their number. So 1 here 1 plus 1 2. Okay, 2 plus 2 4, 4 plus 4 8, 8 plus 8 16, 16 plus 16 32. Like that, it will take in binary operations. Okay. In the same way, we have to give the our binary values under these numbers, then only we can understand. So here left shift operator means yeah, basically the 10 the base binary value of 10 is 1010, but we are shifting two values, so we are giving these values, I mean extra zeros to the right side. Okay, so these ones will and the zeros will move to the left side. Okay, so here I need to represent one more value, that is 0. Okay, but we don't need to consider that one. Okay, for 32 1 and 16 0 8 means 1. So 32 plus 8 means what will be the output of 32 plus 8? 40, right? So that like that it will give 32 plus 8 equal to 40. So the output will be 40. Let's see in practically. So here I am going to open fresh ideally for understanding this. I am reviewing these annotations. Okay, 10, what we have expected 40, right? So see the output, 10 left shift 2, so 40. Like that it will take. Okay, this is the practical example. This is a theoretical example. Okay, you can do more operations for this one, for understanding this one, then only we may get understand. Next, I want to perform right shift operation. Okay, I want to perform right shift operation. How to perform right shift operation? Right shift operator. So in left shift operation, we had added zeros to the right side. For right shift operation, we have to add zeros to the left side. Then the values will move to the right side. How? So here I'm taking the same example. 10 right shift. So here I want to specify 10 left shift 2. So the output will be 40. So I want to consider this example only. So in the left shift operation, we have added zeros to the right side. Okay, now I want to add zeros to the right side. Okay, 0 0. Okay, so it will give one more time. So okay, now it will understand. We can understand. So 10 what is the value of 10 in binary format? 1010, right? 1010. So we had added two zeros to the here to the left side. So this 10 will be moved to out of this one. Okay, so we have to consider the only values which are having one. So the number which is having one is one 2 only. Okay, so we have to consider 2 only. So the output of this operator is right shift operator For the 10, right shift to 2 is 2. See the output. So here ideally I'm going to do the same operation 10. Okay, right shift to 2. So the output will be 2. Like that it will take. This is the theoretical example and this is the practical example. For understanding this, we have to understand first that under not operations. Okay, in our previous sessions I have explained detail in this about this. Okay, if you have any doubt, please watch our previous videos. Otherwise you can watch the same class second time or third time, then you can easily understand this. Okay, these are about left shift and right shift operator. Now I want to perform Boolean operations for this one. Okay, bool means either true or false. Let's see what it will give. Now I want to consider true and false for these bitwise operators. Then let's see what it will take and what will be the output for these operations, bool operations. True and false. True and false. What it will give for AND operations? Oh, true means 1 and false means 0, right? So the rule for this is, wait, if both bits are 1, then only the result is 1. So here 1 and 0, both bits are not 1. Okay, that means it will give 0. 0 means false. So it has to give false. Okay, and for OR operation, I am giving true and or false. True or false. So true or false means 0, I mean 1 and 0, or 1 or 0, 1 plus 0, 1 plus 0. The rule for this is if at least one bit is 1. So here true means 1. We had given already 1. So the output will be 1. I mean 1 means true. Okay, like that it will operate. Next, I want to give this one caret symbol for this operation for that one, and true caret false, true caret false. 1 minute. So true caret false means, what is the rule for this one? If both bits are different, then only result is 1. If both bits are different, then only result is 1. So here both bits are different. I have not given either only true, either only false. I had given difference. One is true, one is false. So the result will be 1. 1 means true. That's why it has given true. Okay. Next, what will be the negation of true? This one. 1 minute, guys. Give me a minute. Give me a minute. 1 minute. So the output of this true is, negation true is, here it will calculate for understanding this, we need to take one formula, that is minus of minus 1 n plus 1. Okay, like that it will operate. So here I'm going to show the formula. Annotate. Next, here I'm going to write negation of negation of 4. Negation of 4. Negation of 4 means minus of n plus 1. N plus 1. Okay, minus of n plus 1. Otherwise, we can take normal text instead of this. Minus of n plus 1. So my n here n value is 4. 4 plus 1 means 5, right? 4 plus 1 means 5. So the symbol for this is, we have specified here minus symbol. So the output will be minus 5. The output will be minus 5. Let's see what it will give. So, and for 1 minute, guys. So true means in the same way, and the true means 1. Okay, 1 plus 1. 1 plus 1 means 2. On the we have specified here minus. So minus that's why it has given minus for 2. Okay, so true means 1. Okay, so n means true. That means n means 1. 1 plus 1. 1 plus 1 equal to 2. 2, we have specified here minus symbol. So minus of minus 2. Okay, that's why it has given minus 2. Next, if we give minus 4, negation of 4, then it will, the output will change. 4. 4 means here 4 plus 1, 5. Minus symbol. So minus 5, the output is. Okay, like that it will operate. Like that it will operate. Okay. I'm going to copy these content in our live class notes. Okay, these are the inputs and these are the respected outputs. This is a practical example, I mean a theoretical example, and this is the practical example. Okay, yeah, that's it for today's session. Today we have discussed about bitwise operators. 1 minute. So in bitwise operators, we are having these kind of operators, that is, one is and, next one or, caret, negation or complement, next left shift and right shift. So the rules for these operators are these. we can apply, first rule is we can apply these operators to bitwise. Okay, bitwise means each bit it will operate. Okay, so here the example, here 0 is 1 bit, and here another 0 is 1 bit, 1 is 1 bit, 0 is 1 bit, so 32 is 1 bit, like that it will take. Okay, bit by bit it will take, that's why it is called as bitwise operator. Okay, next, these operators are applicable for only for integer and bold data types. So what we have given as inputs for these are numbers. Okay, numbers were called as integers, and one more thing, bool means true or false. We have applied those rules to these true and false also. Okay, and we can only apply these operators for only integers and bools, not for string, complex, other data types. Okay, next, the rules for these are discussed here. Okay, for and operator, the rule will be, if both bits are 1, then only it will 1. Okay, so here only the both bits are 1, then only it will give 1. And if for our operator at least 1 bit, so at least 1 bit is 1, then it will give 1. And for complex or this one is caret operator is, if both bits are different, then only it will give 1. Okay, so here both bits are different, 0 and 1, 1 and 0. Here both bits are same, here both bits are same, that's why here given 0. Okay, next, negotiation means one, if you give 1 it will give 0, if you give 0 it will give 1. Okay. Okay, for left shift operator, how we can perform the left shift operation is just by specifying the zeros to the right side, then the values will be moved to the left side. If you give the values to the right side, then automatically remaining values will comes under left side. Okay, how I have shown here. Okay, so if the zeros, if you want to shift these zeros to left side, then these zeros, two zeros will go to right side, and these 101 go come to the right, left side. Okay, that is called as left shift operator, and the values also change. If these zeros are not here, and 1010 are here, then the output will be, so 1 means 8, and here 0 means 4 and 1 means 2, so 8 plus 2 equal to 10, like that it will give 10. Okay, 1 minute. Now we have to consider these values. Okay, 8 plus 2, 10, like that it will operate. But if you shift left side, then the values may change. Okay, and for right shift operator also same. We will give the zeros to the right side, then the values move to the left side. Okay, like that it will operate. Okay, if you have any doubts regarding this session or any previous session, then please comment below. Okay, I hope this video is helpful for you. Thanks for watching.